everyone. Thank you for joining me today. I'm Asaf. I'm one of the co-founders and the CEO at Granulate, a real-time continuous optimization solution. I'm here to talk about new ways of cost optimization and workload optimization. And this is a bit about Granulate. We'll keep it as neutral as possible. I think the main idea that you can take, or the key point from this slide, is no code changes. I think it's something that is emerging and we'll talk about in general. I think it's going to be key for 2021. And to talk about 2021, we need to first talk about what was happening in the past. And with the shift to the cloud, there's been a huge increase in solutions of cost reduction and a lot of ways to go about it. This could be anywhere from the cloud hygiene solutions, things that tell you, how do you know that you didn't lose some machine running somewhere or an EBS running somewhere if you're on AWS. You have different sort of instance types, and or if you're on GCP, you can vertically scale and your machine, regardless of the memory and CPU. We've got scheduling operations allowing us to shut down our machines when we go home and bring them back when we come back, our test environment or dev environment. And we've got a lot of discount purchasing types, things like spot instances, things like reserved instances, and so on. All of these are the sort of best practices in what we like to call sort of cloud hygiene. I think it's clear to see that if you're an organization moving to the cloud and you haven't implemented any of those, then your TCO is going to go up way high. If you're born to the cloud, then you're naturally familiar with these, and you're probably already implemented those as you scale. But with COVID and with 2020 came a lot of new challenges that we had to tackle. And so cost optimization became a huge, huge priority for a lot of organizations. And you want to cut costs where it matters, in your OpEx and your production environment, and not your manpower, because you need that to continue innovating. And so new ways of cost optimization have emerged based on automation, based on artificial intelligence, which allows us to increase, and complementary to all of these, increase our cost saving by tens of percentages, sometimes reaching all the way up to 80. Now we'll talk about a few problems. So first of all, it's becoming more and more complex our environment becomes more and more complex. We have different teams in charge of different services. We have problems seeing the end-to-end optimizations. But what we like to talk about is not just the complexity of the architecture, but also on the machine itself. So what we're seeing with a lot of organizations is that they're running on anywhere between 20 and all the way to 40, let's say, % utilization. That said, even through microservices, if they were to reduce that infrastructure size by 50%, in theory, running between 40 and 80%, they should have been fine. However, what we're seeing is that when that happens, they experience a lot of latency spikes and performance degradation, which means that if we hurt our customer experience, we might hurt revenue. So a lot of organizations choose to solve that issue by actually running at very low utilization. But then what happens is that they don't actually solve the problem. They obviously solve what's caused by the contention of resources. And so there's not only paying for the underutilized machines, but they're also probably not getting the best performance, because you'd expect that running at 40 to 80% would have been fine, and you would be right. And this is what we're going to talk about today. So this is a maturity model that was curated about the resource management optimization, both in the cloud and on-prem. So we started with the best practices, all those things that you had to implement, things like when we shut down machines, when we know, and then we moved on to those monitoring and visibility tools that allowed us to finally understand what's happening in this huge, huge world of all of a sudden we have to pay attention to data transfer and to our storage and availability zones and so on. On top of that, there are a few things that we're seeing. On one side, you need to implement cloud management tools, and so to understand where all of your resources are. And then you can start talking about workload orchestration, and we'll go into details of what it is in just a moment. After you've implemented some sort of workload orchestration, what we see is a lot of organizations sometimes insert configuration tuning capabilities as well. That's on one side. On the other side sits what's happening within our own VM, which is the real-time continuous optimization. What is happening on our own server that we can optimize to optimize the macro level of the cluster itself. This is obviously irrespective of the cloud management tools because it's about the single VM. Now, if we put it on a matrix, we can put it on a performance versus cost matrix. So how much do I impact performance versus my cost effect? And we can see all the legacy approaches and legacy solutions, things like APM and AI ops, which are aimed more at manually researching my performance, aimed at alert consolidation, root cause analysis, and so on. Alongside cost monitoring and optimization solutions, who are aimed at giving me the insights into what I should do next. Do I do right sizing? Do I do spot management, and so on? These are very automatic, not necessarily as manual as APMs, but their effect is mainly over cost reduction. Above those, we can see one of the three new approaches that we talked about, which is configuration tuning, workload orchestration, and real-time continuous optimization. What is similar across all of these is that all of these are aimed at being autonomous. So no maintenance, no code changes, simply out-of-the-box improvements. Configuration tunings helps us automate the knob tuning alongside many knobs and components that we have in our production system. Workload orchestration helps us in real time to decide which instance types and what provisioning to do and where to place our workloads. And real-time continuous optimization focuses on the performance optimization and adapting the machine itself to the workload running on top of it. So obviously, real-time continuous optimization touches on the performance improvement and also the cost reduction, because if we can handle more traffic with less, then that's what's happening. Workload orchestration focuses more on the cost effectiveness. If I have a machine running at 10% utilization, it might switch that to a lower instance type, hence running at 20%, let's say, but still, it definitely won't help me improve performance. And configuration tuning, we put it under automatic because it's not real time, affects both. However, if we look at how it works, so we have multiple components in different parts of the stacks. This could be anywhere from our syscontrols and all the way up to our application level. But the truth is, as is with any configuration, it has diminishing returns over time. So first, out of the box, this might give me a huge bang for my buck, but not necessarily, again, similarly in a month or so, as we don't introduce many components every month. And the best practice configuration is usually good enough. When it comes to resource orchestrators, we're talking about provisioning, placement, and sizing, meaning I have a certain size of my cluster. I need to increase it and decrease it over time. I need to play around with a threshold. This could be the CPU usage. This could be the amount of queries per second. This could be the amount of the latency SLAs that I'm seeing, 90th percentile, 99th percentile, and so on. So this helps me automatically abide by those SLA that I define, which can be very difficult given the fact that we have multiple complexities around that. This could be auto-scaling groups. This could be pod resource requests, for example, in Kubernetes. And the same goes for the HPA thresholds, the horizontal pod autoscaler in Kubernetes. And so these tools help me do that automatically, and they maintain my SLAs for me. The same goes for making sure that I'm in a cost-effective instance type, or with pods, making sure that I get the most bang for my buck by reducing the amount of requests that my pod has. So it also vertically scaled my pods, not necessarily just horizontally. This is basically how these workload orchestrators operate. They collect the data around whatever it is that we're looking at. This could be our virtual machines. This could be our Kubernetes cluster. This could be our container cluster, and so on. They analyze what is happening, what they can optimize, what is underutilized, what is overloaded, which pods might be incompatible and put on the same node. So they might need to be in different nodes, and so on. This gives us both insights and sometimes allows for automatic actions to happen. But once again, as mentioned, it's aimed more about the cost effectiveness, not about the performance necessarily. In real-time continuous optimization is basically around the machine itself, as we mentioned, not necessarily about the entire cluster, and we'll show how it affects the entire cluster in a second. Basically, it takes the operating system and kernel who is managing the contendable resources, so CPU, network, memory, locks, disk accesses, and so on. It manages them in an interactive and fair way, aimed to sort of give us an optimal performance across multiple services. And what real-time continuous optimization does is trying to take that and align it to our optimization function. So no longer does the kernel make decisions based on general purpose, again, interactivity and fairness use case, but our own use case. So in our production servers, we look at the SLAs, we look at requests per second, we look at network traffic. So this could be amount of bytes per second, and this could be the IOPS and so on. But we have a metric that we follow to understand our customer experience. And what real-time continuous optimization does is it looks at the same metric and optimizes the resource management within that machine in a feedback loop created way to allow us to gain better performance. This is what it looks like. Basically, our data flow, when a request comes in, could be processed on the CPU, then go out to the network, and then we're waiting on a mutex for, let's say, a data structure, and then we're reading some data from the disk or writing data from disk, and so on. From our operating system perspective, it's basically an unopinionated kernel trying to give everyone the amount of resources it thinks they should get so that everyone can move on as fast as they can, but not necessarily the end-to-end metrics. And so once you apply real-time continuous optimization, everything acts according to the end-to-end metrics. So the end-to-end latency, and not necessarily the immediate one. And let me show you why it's important. So let's assume that there's a single server on service A, and this is how we do the micro single server all the way to the macro service level. And that server is an API server receiving, let's say, a login request. And when a user logs in, we don't only want to just say that he logged in successfully, we also want to give him some, let's say, recommendations, some insights, queries, history. We can give a quick example about Netflix, for example, where you log in and they do about 250 to 300 requests on the back end, meaning they don't want to just verify that you logged in correctly. They query the history, they continue watching the trending, what's new. They even customize all the thumbnails per the person watching. And so, since a lot of these are independent, they run independently in parallel. And the thing is, as the world works, some of these services are going to return a lot faster than the others. For example, what's trending has nothing to do with me personally, but maybe my country. And so that would come back from, let's say, a cache mechanism very fast. And I would still be waiting on my history because, let's say, I have a 7 years history on Netflix. And so from a kernel's perspective on this server right here, for this particular application, for this particular request, I can process the data from service X. However, if we look at the global application of that, is that I'll be able to process service X's data, but I'll still be waiting on the history and everything else. But this is not the only thing that this server is doing, because it processes anywhere between tens of thousands of requests at the same second. We're not processing just one request on a single server. Otherwise, that would be incredibly not cost effective. And so maybe not processing the data from service X right now might be a smart move, because let's say we have a new request coming in and we need to send it to all the other services. Or, for example, there's a different request for which all of these services have already returned a response. And so we might want to prioritize that higher. But right now we don't have that ability, because not the operating system or the application is able to do that at the moment. And so these will be file descriptors that the operating system will just push up to the application if it calls on it, or if it's a threaded application, it will wake these threads up. Now, obviously for us, let's assume that we have two requests that we were thinking of which one is a higher priority, one that has returned that all of the services have returned for and is ready to be processed and sent back to the user, should probably take precedence over one that has just returned the service X. But the kernel has no ability to understand that at this moment. It has no ability to prioritize between tasks of the same process. Different processes, there's a mechanism called niceness, but that's a different story. And since the kernel was built for interactivity and fairness, it's pretty good at distinguishing between different processes. Real-time continuous optimization allows augmentation of that into the level of the tasks. So you can align your production optimization function, which is latency, throughput, IOPS, whatnot, with what the actual kernel is deciding when it allocates different resources to different threads. Now, this is why all of these are important. And we presented today 3 different approaches on how to optimize performance and costs with no maintenance and no code changes required, whether it's configuration tuning, workload orchestration, or real-time continuous optimization. And since to continue from 2020, we believe that cost optimization will remain a much higher priority for a lot of organizations as they shift to the cloud and to remote work has increased usage by a huge amount. And a lot of organizations have implemented FinOps functions and head of cloud infrastructure functions within the organizations. Operational efficiency becomes a huge priority. We will see that moving forward. This will be automation, autonomous tools, especially around cost optimization and performance improvement. Thank you.